Hello viewers all over the world. This is Afe Ademola Johnson, your chemistry tutor. With reference to the previous video where I've been able to create a background understanding about the number 2 question of 2024 NECO chemistry practicals. So we want to look at the practicality of what we have spoken in the previous video. If you have not watched the video, please go and watch that video. It's there, it's already posted. Now, we want to follow the instructions that are given in this place. If you look at this table, we are asked, this is C. We have to put C, which is our zinc chloride. Our zinc chloride. So you can see from here, they say plus water, distilled water. So I want to add water to it now. The essence of adding this water is to know whether the salt is a soluble salt, whether it can dissolve in the water or not. As you can see, you will notice that the salt dissolves totally in water. You will not see any particle from it. So it's a soluble salt. And this is how to report this. When you have this, you shake it. You can see they say shake thoroughly. So we are shaking thoroughly now. Shaking thoroughly. If you look at it very well, you see that the salt has fully dissolved. So what do you now write here? You now write, you say C dissolves. C dissolved, report in past tense in distilled water to form colorless solution. And that suggests that in your inference you say soluble salt is present. That this salt that can dissolve in water is soluble salt. Soluble salt is present. Don't forget, zinc chloride is one of the soluble chlorides we have. It's one of the soluble chlorides that we have. So now, so we are asked to divide the resulting solution into 4 portions. Into 4 portions. So let's see what happens to the first portion. Now, to the first, they say first portion of solution C plus NaOH in drops. So if we had NaOH in drop, with me here is NaOH. So if I add it in drops, let's observe what happens. Can you see some white precipitate, some white particles that is like NECO that you can see from here? So you can see all those particles, you can see it from the body of this container. It's that gelatinous, white gelatinous precipitate. So in drops, say white gelatinous precipitate. White gelatinous. Let's now add it in excess. In excess now. In excess. In excess. Let's add it in excess. you will see that the thing is dissolving. The white gelatinous precipitate is dissolving. It will dissolve totally. You will not see anything there again. All those white gelatinous precipitates will soon dissolve. They are dissolving already. You can see it's already dissolving. Can you see? They are not as cloudy as before again. Dissolving. So you report that white gelatinous precipitate which dissolved in excess NaOH. Please put this AQ. If you don't put it, your mark will be deducted. Be very careful. So the ions that can give you this kind of thing, we have aluminium Al3 plus ion, comma, Zn2 plus ion present. So that is that, about that. Now, then to the second portion. To the second portion. To the second portion, we are asked to add aqueous ammonia. This is my aqueous ammonia solution. In drops, it's also going to give me white precipitate. And that white precipitate is going to also be what? Zinc 2. Can see? Immediately I add, can see my white particles. Just white gelatinous precipitate. You can see it. Can you see? So, but it's dissolving now because I'm adding it in excess. You will not see it again. So, can you see? So, that is that. So, you can now report and say, here also, white gelatinous precipitate, which dissolved in excess and ammonia solution. Please always write this AQ. Then you also have what? Al3 plus. Al3 plus. Okay, it's going to be Zn2 plus ion present. Why did I not put Al3 plus? I'm not putting Al3 plus because aluminum hydroxide cannot dissolve in excess aqueous ammonia. So that is why I'm using Zn2 plus ion. So that is that. Now, that's right. Alright. Now we can come here. Then the next one says the third portion. The third portion. Okay. So since the thing got exhausted, so let me just to the third portion of solution C. So what did he say we should do to that? To the third portion, he said we should add HNO3 first. We should add HNO3 followed by AgNO3. So this is HNO3. If I add HNO3, you are not seeing anything. No visible reaction. But the essence of using it is that to prevent the precipitation of foreign ions. Just like no visible reaction. No visible reaction. And in your inference you put dash. So that is that. Then, okay. Now, then they now say after adding the HNO3, then you now add AgNO3. You are adding AgNO3. You are adding AgNO3. Want to add AgNO3? So, okay. AgNO3 is always present inside a dark bottle, because if not, it will, when exposed to the light, a photochemical reaction will take place and silver metal will be formed. So what do you notice? A white precipitate of silver chloride has been formed. White precipitate. White precipitate. White precipitate is formed. White precipitate is formed. The only ion that forms white precipitate when you add AgNO3 then is what? Is chloride ion present. But they didn't stop there. They said we should add aqueous ammonia. We should add aqueous ammonia. So by the time I add aqueous ammonia, the white precipitate is expected to what? To dissolve. To dissolve inside and to dissolve. You can see that you are no longer seeing the particles again. The particles are grounded now. They are not there again. So it means here that the white precipitate dissolved due to the formation of a complex ion. A complex ion, which is diamine silver 1 ion. Diamine silver 1 ion. White precipitate is formed. Then you cannot say precipitate, white precipitate dissolved in NH3 aqueous. So lastly, to the fourth portion, they say we should add we should add lead. We should add lead nitrate. Lead nitrate, PbNO3. You can see what I'm doing here. It's expected to turn white. Can you see? It turns white. So that is lead chloride. So now, from there, then they say we should eat white precipitate. Soluble on heating and reappears on cooling. When cooled, then chloride ion is present. Let's try to eat this one. Watch me as I eat. This is my test tube holder, my boiling tube holder. Then the matches. So I put on my gas. Okay. Watch me as I eat. Don't forget, lead chloride is only soluble in hot water. That is why this white precipitate will become soluble when heated. But when I allow it to cool, the white precipitate reappears again. So that is what you are seeing now. Okay. Can you see any white particle inside again? Everything has dissolved because zinc chloride is soluble in hot water. But if you give it a time, let me put it in cold substance. You will see that later on the white precipitate will reappear again. Can you see? The white precipitate is already appearing again. It's appearing again. So we have done justice to the practicals. So that is what is expected of us. So with what we have done here, I believe I've been able to prove to you how these likely questions will come. So when you have done this, after you have done this, you don't just stop. You will discover that at the end of the day, we have been able to discover zinc 2 ion and chloride ion. Then you can now come to a conclusion, and your conclusion will now be this. Your conclusion will now be that since C contains zinc 2 ion and chloride ion, then C is zinc chloride, ZnCl2. So that is that. So you can see, let me show you the table clearly so that if you want to write, you can write so that you study. So thank you very much. I remain my humble self, Afe Ademola Johnson. God bless you and bye for now.